use a hypervisor instead. So especially if this is a functionally safe ECU, if you have a multi-core ECU, you can dedicate some of your cores to a POSIX system, and you can dedicate some of your cores to a AUTOSAR Classic system. And once again, you can exchange data between them using a interprocessor link or interprocess link even. But once again, these are fairly still isolated systems, so they're not really closely connected. Now this brings us to adaptive AUTOSAR, and this is the vision moving forward when we want to use a POSIX-based environment within the vehicle. And the main difference here that you'll notice is the system is fully running a POSIX operating system, except what we're doing is we're going to add a middleware layer on top of that existing POSIX system, and that middleware layer is adaptive AUTOSAR. So adaptive AUTOSAR is a middleware layer that sits on top of an existing POSIX system, and that middleware layer standardizes the services and the interaction with all of the POSIX processes that sit on top of it. So essentially all of these POSIX processes, which will interact with the AUTOSAR adaptive middleware layer, these are now considered adaptive applications. And so each one of these adaptive applications is unique. It's essentially compiled as its own binary. And they use this standardized method of interacting with the middleware layer and in turn through the operating system. So in this way, we're bridging the two worlds. We're giving our access to the AUTOSAR APIs and functionality to any process in the POSIX system now. It's not isolated. We don't have to go through some IPC channel to get to our AUTOSAR stack. It's available to every application. Okay, all right, so now let's take a closer look at the modules inside of a adaptive stack, and let's see how those individual modules compare to a classic solution. All right, so on this slide here, we've got a direct comparison on the left-hand side. You can see that is the layout or the architecture of a AUTOSAR classic stack. And on the right-hand side, we have our AUTOSAR adaptive platform. So if you're familiar with AUTOSAR Classic, you're probably aware that there are a lot of modules, a lot of small distinct modules that all have their own very specific task in the system. AUTOSAR Classic runs in a bare metal environment, or it's designed to do that at its core. And so we have a lot of low-level peripheral drivers that you see down here at the bottom. There's a lot of kind of interface layers in between here, and then a number of various service components. We have a dedicated OS, which is specified by the AUTOSAR consortium. And essentially all of this is designed in C. And we support a number of serial bus systems. We can use CAN or FlexRay or LIN or Ethernet. And when we design the system, we build everything into one giant binary. So we take all of our application code, all of the basic software, operating system, it's all compiled together into one big binary. Now let's contrast that with AUTOSAR Adaptive here. In AUTOSAR Adaptive, you'll notice we have much fewer modules than we do in the Classic platform. So on Classic, where you have potentially up to 100 modules, depending on your specific ECU configuration. With Adaptive here, you're really only looking at a handful of modules, which you see here. And in the adaptive world, they call these modules clusters. And so these various clusters provide some services, some automotive protocols, which are similar to or the same essentially as the Classic platform, which gives us our possibility to interact with the rest of the bus. But you'll notice that without having to do any direct hardware interaction, because we're now a middleware layer sitting on top of an existing operating system, we don't need all of these hardware drivers. We don't need a AUTOSAR specific operating system. We sit on top of a existing POSIX OS. And so therefore the amount of clusters or modules that we have here is highly reduced. Now, since we're dealing with POSIX, we're dealing with developing applications and all the code is written in C++. And one other important difference which comes along with using a POSIX operating system is our serial communication bus is now limited to Ethernet. So Ethernet is directly supported by POSIX operating systems, but unfortunately other buses like CAN, LIN, and FlexRay are not. And so when we're talking about an adaptive ECU, one very important consideration is that we're talking about Ethernet-based communication now, rather than say CAN or LIN or FlexRay. And since we're going to be dynamically loading applications individually, these applications will be compiled as separate binaries from the middleware layer. So we no longer are compiling one giant binary, but there's one binary for the middleware layer, and then we have separate binaries for each application software component. So just to give you a quick overview of the various clusters that we have here. So time synchronization, this provides the same AUTOSAR modified GPTP protocol, which is used in AUTOSAR Classic domain. And here, execution management. Execution management provides startup and shutdown of individual applications in the automotive domain. So because we're dynamically loading applications, we need a way of controlling when those start up and when those shut down. Diagnostics here, this is roughly the equivalent of DCM and DEM in the classic domain. So this is providing UDS kernel support and also DTC handling. We have communication management. This is roughly the equivalent of RTE plus COM in the classic domain. So this is the main interface to the application for doing any kind of serial communication or talking either between ECUs or also between different processes within your own ECU. We have platform health management. This is roughly the equivalent of a watchdog stack. We have logging and trace. This is very similar to or provides the same AUTOSAR DLT protocol as with Classic. So we can connect an external DLT compliant tool and we can read out error codes returned by applications, or we can read out some internal variables and just kind of high level debug information. We have persistency. This is the equivalent of the AUTOSAR Classic NVM stack. This provides access to non-volatile, what they call key value storage for storing individual pieces of information like NVM blocks. And then there's also file stream based storage if you want to use that. Identity access management. This essentially is a security module, so you can define restrictions for applications that are downloaded to the ECU. And when applications are downloaded, this module will enforce those restrictions. So, maybe a certain type of application isn't allowed to access the Ethernet bus, for example, or it's not allowed to talk to some other application within the module. So you can define those rules in this identity access module. We have an implementation of REST here. So this is for server-based communication with a web server, I mean. So if we need to exchange data with the cloud, and if that cloud server is based on REST, we have the ability to interface with that. We have a cryptography module here, essentially providing the same services that you would have in an AUTOSAR Classic ECU. So things like MAC generation, MAC verification, encryption, decryption, random number generation. And then over here, we have services like AUTOSAR Network Management. This is the same network management used in Classic. We have a state manager. State manager provides more discrete control and customizing different operating modes within the ECU. And based on those custom operating modes, you have more control over starting up and shutting down individual adaptive applications. And then finally, we have the update and configuration management module. And this module handles loading and unloading of applications into the ECU. This is essentially how we get new applications onto our ECU. Okay. All right. So a couple other important differences with the Classic platform, since we're usually running in a bare metal environment on a simpler operating system, we have more deterministic behavior. So we have better real-time performance in a Classic environment. Where with an adaptive environment, we have a higher class of processor. but also more complex operating system. So that means we have more computing power, but then the trade-off to that is our startup time is going to be slower. And in both of these cases, we do have functional safety as an offering up to ASIL level D. And so that, depending on your functional safety requirements, is available on either platform. Okay, so this is what an adaptive application looks like. Essentially, it is typically one process consisting of multiple threads, and each adaptive application has an init code section, a normal runtime code section, and then a shutdown code section. And this is invoked by the execution manager component that I was mentioning on the last slide. So if the execution manager wants to start up an adaptive application, your adaptive application will execute this init code and then go into run mode. And then likewise, when you shut down, you'll execute your designated shutdown code. Each adaptive application has a separate set of configuration files that goes along with it. So the configuration for the application is stored separately from the binary itself. And this configuration is referred to as manifest files. So a manifest file basically describes to the execution manager, to the running system, essentially what type of services and interaction and dependencies that this particular application has. So for example, does it have to run on a specific core in the microcontroller, and which services does it plan on accessing? That's described by these separate manifest files, which essentially are just XML. Each adaptive application has three different interfaces that it's allowed to access. So first, an adaptive application is allowed to access the OS directly through the PSC51 subset of interfaces. There's also the COM interface, which, as I mentioned, is more or less the equivalent of the RTE in Classic. So if it wants to exchange any kind of data with other ECUs or with other processes running on this ECU, it can use these COM interfaces. And then finally, we have what are called direct APIs, which are essentially the services provided by the middleware layer, things like watchdog handling or non-volatile memory management or identity access. If the application needs to talk to those components, it can use this direct API here. So as long as the application that you design is compliant and it uses these interfaces exclusively and you don't use anything else, then you are guaranteed portability from one adaptive ECU to another. You can simply download your application to a new ECU, and because the standardized interfaces are all available, then it should work just fine. Okay, so let's take a look at the tooling involved here and a bit of the workflow. So how you approach designing for adaptive AUTOSAR. Okay, so first a little bit of note about the products that are available. So this is a simplified model of the adaptive middleware layer. And essentially Vector has implementations for most of these components, except for the ones that are kind of highlighted in this kind of grayish box here. So the DDS protocol, distributed data services, is something we don't have yet. Robot operating system protocol, we don't have that. And then the state manager module, which provides that more granular control over customized operating states. That is something that is still under development at this point. But other than these three modules, essentially, we could offer any of the others currently specified. And then to interface the middleware layer to the underlying POSIX operating system, we have what are called OS abstraction layers. And these are just like a thin glue layer connecting the middleware to the underlying operating system, because each operating system does have some variations in its APIs. And so we currently support Linux, PikeOS, and QNX. And if there is another operating system, POSIX operating system, then that can be supported as well. The main requirements for your operating system is it does have to offer the PSC51 subset of interfaces, and it also does have to have the capability of dynamically loading and unloading applications. So if your underlying POSIX OS has that capability, then we can design an OS abstraction layer to make the middleware run on your OS of choice. All right, so now those of you that may be familiar with AUTOSAR Classic, you're probably familiar with DaVinci Configurator and DaVinci Developer, which are Vector's tools for configuring and designing for AUTOSAR Classic. And those are very GUI based driven, very point and click, check boxes and pull down boxes and, drawing stuff in the interface essentially. And so one big difference here with adaptive is we've gone with a more kind of coding approach using a shorthand scripting language rather than a GUI-based approach. So for the adaptive platform, there is essentially we're going to use a generic Eclipse environment, and instead of essentially customizing the entire environment, we have some plugins, some helper modules, some new views that will represent the data in a much easier to understand way and assist you with going through the process of developing applications. And we'll see that in a little bit better detail on the next slide here. But essentially, you'll be using an Eclipse environment, and that will invoke our code generators so that you can create those manifest files we were talking about, which essentially are the configuration for the application, and also generate any of the headers and the C code necessary for like your service interfaces for the application, and also anything necessary for the basic software as well. Okay, so from a high level here, the first thing that you're going to do, which is similar to Classic essentially, is you need to design your services and your interfaces that are going to be used either for your specific application or if you're an OEM, then maybe you're designing for what you know up front for the entire vehicle. So our prevision tool is still used for this particular part of the process. So with prevision, we have capability of exporting in the AUTOSAR adaptive manifest format as opposed to the ECU extract format that you're used to with Classic. So if you're a user of prevision, the great news is you can keep using prevision. You don't have to switch to another tool. You can use essentially your existing design even, and you just export in a different format. Diagnostics in terms of services and DIDs and routines is going to be handled by Candela Studio. So that is also essentially the same as AUTOSAR Classic, and we're using the DEXT, DEXT interchange format, which was also used for AUTOSAR Classic. So you end up with these manifest files, which at their core are just ARXML files, just like in Classic, just using different tags essentially. And we can use those inside of Canoe if we want to do some simulation or testing. And of course, the big use is to plug them into the DaVinci toolchain so that we can go ahead and finish our application. We can generate our code and essentially get everything ready to be compiled for the ECU. So the DaVinci tool for adaptive is called DaVinci Adaptive IDE. Or also sometimes referred to as DaVinci Adaptive Tool Suite. But essentially, we're not using configurator and developer anymore. It's called DaVinci Adaptive IDE. And that would be the tool when you're going to generate your code and essentially get ready to build the application or the middleware layer. Okay, so you have your authoring tool, you're designing your interfaces and your services. Then you're plugging that into your essentially your application design tool or your middleware layer configuration tool, which is DaVinci Adaptive IDE in both cases. That's generating some header files that you will need to compile. And you're compiling your application into its own separate binary. And along with that, you have these manifest files, which are separate from the binary. These describe essentially the configuration options for your application binary. And then finally, assuming that you had previously built the middleware layer and you've already got a POSIX system running that middleware layer, you are simply downloading and installing your individual application binary along with those manifest